All right, so I pressed the wrong button on the last video, and it just cut it off. Instead of pausing, I ended the video. So this is going to now be 3 videos long. So I've done that a couple times now when making this video. All right, so for number 8, it says find all 6 trig ratios for the given angle. So first off, there's going to be 6 that you have to answer. So 6 answers. And we're finding the ratios. Once you see ratios, that means that we're answering fractions. Unlike the last problems that we were doing for 6 and 7, where you're solving for the missing sides and angles, here it doesn't ask you to solve for anything. They don't want to know what this angle measurement is. We do eventually have to solve for our hypotenuse so that we can get our ratios, but all we want to have is just all of our fractions. Right? And before we can start solving for our trig ratios, we have to solve for our hypotenuse, because we know our trigonometry is going to use our Sohcahtoa. So if we are going to need our hypotenuse, we need to know what that answer is. So we're going to do that first over here, where I know my 4 squared plus my 2 squared is equal to my 8 squared. Well, my 4 squared is 16 plus 4 is equal to 8 squared. 8 squared is then equal to 20. Take the square root of each side. H is then equal to plus or minus the square root of 20. We will reject the negative, and you will have to simplify that radical. So h is equal to 2 root 5. All right, so now let me erase all this work off to the right. But now that we have all of our sides, we can go ahead and start solving for this. So we have our hypotenuse. We know that the side that does not touch the angle that we're highlighting is our opposite. And then the side that creates our angle that is not our hypotenuse is our adjacent. So now our 6 trig ratios, our first one is going to be sine of theta, cosine of theta, and tangent of theta. Those are the ones that we should know with this Sohcahtoa. And then we will have to solve for the reciprocal ratios, which the reciprocal of sine is cosecant of theta. The reciprocal of cosine is secant of theta. And then the reciprocal of tangent is cotangent of theta. All right, so we need to solve for all 6 of these. And I'm going to go through and give you guys some tips or some things that you should look for or that you should do first. But since you have a calculator that you're allowed to use now, and since your calculator will simplify these fractions for you, you will go ahead and you can just type this into your calculator and it will simplify it for you. But if you're doing this by hand or your calculator doesn't simplify it for you, then you should follow what I'm saying here first, because it just makes it a little bit easier for you. All right, so our sine we know is equal to our opposite over our hypotenuse. So here's our opposite, here's our hypotenuse. So our sine is 2 over top of 2 root 5. All right, then we will simplify. 2 and the 2 can reduce, so we're left with 1 over root 5. Before we go ahead and before we rationalize our denominator, flip it for our cosecant, because we know it's our reciprocal. If you rationalize it first and then take our reciprocal, you're going to have to rationalize again. So before you rationalize, flip our fraction, take its reciprocal, and we're left with the square root of 5 over 1, which is just the square root of 5. So if you write it like this or like this as an answer, that's perfectly fine. All right, so do this before you rationalize. And now if we want to rationalize, you can just type this into your calculator. However, if your calculator does not do it for you, we need to say, well, what do we need to multiply root 5 by to get rid of our root? And we know root 5 times root 5 will cancel each other out. So I'm going to do this work over here. So we're left with root 5 over top of 5. All right, so let me erase this. And our final answer for this sine is square root of 5 over top of 5. If you have anything else, that means it's not fully simplified, and all fractions need to be simplified. All right, our cosine is going to be adjacent over hypotenuse. So it will now be 4 over top of 2 times the square root of 5. Same thing as before, reduce, so now we're left with 2. Before we try to rationalize, flip it. All right, if you have your calculator, it does this for you. It doesn't matter the order that you do this. It's going to just give you the answer anyway for you with rationalizing it. But if your calculator doesn't do it, flip it first, and we're left with the square root of 5 over top of 2. And there's our secant, right? Because we know our secant and our cosine are reciprocals of each other. Right? Now, if we want to solve for this one, we will multiply by the square root of 5 over square root of 5, so that way we can rationalize. And I'm going to write it off over here. So our 2 times the square root of 5 is 2 root 5 root 5 times root 5 is going to give me 5. So that is our final answer. Let me erase this and put it next to it. All right, so then our final answer is 2 root 5 over top of 5. That is our rationalized and completely simplified fraction of cosine. All right, and like I was saying, when you have a radical in your denominator, if your calculator doesn't do this for you, or if you're just doing this by yourself, which I would prefer, take your reciprocal before you rationalize. Otherwise, you will have to rationalize again for your reciprocal ratios. And then our last one, our tangent, we know is opposite over adjacent. So this one's nice and easy. It's just going to be equal to 2 over 4, which we know is then going to be reduced to 1 over 2. So our tangent is 1 over 2. Since there's not any radicals, it doesn't matter about when you take your reciprocal. We know our cotangent is a reciprocal of that, so you can write it as 2 over 1 or 2. Either one is acceptable. All right, this one says if tangent of x is equal to 12 over 5, then find cosine of x. So we know once we see tangent and cosine, that means we're dealing with our right triangle. So I'm going to go ahead and draw a right triangle just to help me solve this problem. I'm just going to pick any angle I want. I'm going to say, all right, I'll highlight this as my angle. And now I'm going to fill in my sides. I know that this is going to be my hypotenuse. I know that the side that does not touch my angle is our opposite. And then the side here that does help create our angle with our hypotenuse, that is our adjacent. And in here, it tells me that my tangent is 12 over 5. Well, I know that my tangent of my angle is equal to opposite over adjacent, and it tells me that it was 12 over 5. So that means my opposite must be 12 and my adjacent must be 5. So my cosine of x, I know is equal to adjacent over my hypotenuse because of our Sohcahtoa. Remember, we're going to use our Sohcahtoa. So that means that my cosine is adjacent over hypotenuse. So when I look here, I do not have my hypotenuse, but I have a right triangle and I have 2 of the 3 sides. So I can easily solve for this by saying, well, 5 squared plus 12 squared is going to be my hypotenuse squared. So then it will give me 25 plus 144 is equal to my 8 squared. 8 squared is equal to 169, square root of each side. H is equal to plus or minus 13. Reject our negative, so our hypotenuse is 13. And now we know our cosine is adjacent over hypotenuse. So then our cosine of our angle x, is equal to our adjacent over, so 5 is our adjacent over our hypotenuse, which is 13. Let me write that a little bit. For some reason, this is not writing smoothly. You see that circle kind of just went wild there. So just hopefully you can understand the handwriting, follow my words, I'm saying it, which is not writing very smoothly right now. All right, and this is it for the final answer. So once we're given one of our trig ratios, so in this case we're given tangent, we can go ahead and create a right triangle and solve for the rest of our trig ratios by just filling in what we know and solving for the unknown using Pythagorean theorem. All right, on to the next question. All right, so for problem number 9, you are given a congruency statement, and you need to use this in order to solve for any missing variables. So first, let's look and find our variables. So the first one I see is I see x here. And I see x is my angle B. So then what I'm going to do is I'm going to look at my congruency statement and find my angle B. So it's a second letter written. So that means it's congruent to angle E, because that's the second letter written, because remember, corresponding parts are congruent in congruent triangles. So that means it's congruent to this angle. However, we do not know that angle. It's unknown right now. So then we need to look and say, well, here I have one angle and here I have one angle. So the unknown angle in this triangle is this angle C. And let me see what C is equal to. So angle C is our third letter, angle F is our third letter, so that means C and F are congruent. So since I know that this angle is 105, I can add it here because they are the same. So now I look here and I see, okay, I have 2 angles that are provided for me and one missing one. I know a triangle adds up to 180 degrees, so I can go ahead and do 35 plus 105 plus x is equal to 180 degrees. So x plus 140 is equal to 180. Subtract the 140. I got the 140 by just adding 105 and 35. So x is then equal to 40 degrees. All right, so sometimes it's not just flat out provided, oh, this is equal to this. Sometimes you might have to do a little bit of work. All right, now the last part, I look and I see here I have my y, 3y plus 1. My y is part of this segment DE, so I look and say, okay, segment DE is the first and second letter. So I look at the other triangle, the congruency statement, so that means it's congruent to segment AB. Well, here is our AB, and they tell me it's equal to 19. So now I can quickly and easily solve for this because I know AB is congruent or equal, so I know AB is going to be congruent to segment DE based on our congruency statement that I showed you. And now that means I know that 19 is equal to 3y plus 1. Subtract the 1, 3y is then equal to 18, divide each side by 3, and y is then equal to 6. All right, that's it for question 10. Let's move on to the next one. All right, same thing. I'm given a congruency statement, and I'm asked to solve for any missing variables. So the first variable that jumps out to me is this 2y minus 8. So I look and say, okay, well, 2y minus 8 is this segment MO, and MO is the first and third, so that means it's congruent to the first and third in the next triangle that's written. All right, so that means it's congruent to TV. So here I look and find TV. Well, TV is 5y minus 11, so it's nice and easy. It's both my y's are in the same part. So that means they're corresponding. So I can then just say 2y minus 8 is equal to 5y minus 11. So I'm going to just add over 11, subtract 2y, and now I got 3y is equal to 3, divide each side by 3, and now y is equal to 1. All right, so now I solved for y. So let me go ahead and solve for x now, and I see here's 10x minus 12, and that's part of segment NO. And NO is our middle and our third one. So I'm going to look for our middle and our third vertex here as well, and that's UV. And UV is here, which also has x in it. So it works out nice. So my x's are corresponding, so I can just go ahead and set them equal. So 10x minus 12 is equal to 4x plus 15. I can then subtract over 4x. I can add over 12. And now I have 6x is equal to 27, divide each side by 6, and x is then equal to 4.5. So it's nice and easy. I solve for both my x and my y. All right, sometimes, like the last problem for number 10, we had to do a little bit of work to solve for the missing part. Maybe that happens for this triangle as well. Maybe I give you that this is a right angle, and I don't give you x in the same location, but I give you that this is 2 and this is 8, and you can then solve for the missing side of our triangle. All right? There's always going to be enough information provided for you, but sometimes you have to look and be able to identify, okay, well, the x in one triangle doesn't correspond with anything that I know right now, but can I solve for that missing part? We did that with the angle measurement. Maybe you'll have to do that in another way on your test. All right, so for the remaining 6 of them, I'm going to try and do these 2 at a time. I'm going to try and get through these as quick as possible just because I know that this video has been really long so far. It is going to be put up to where you can skip through, so the length of it, just skip through to the problems that you need help for, or just kind of go through my examples just quickly if you kind of get it, but maybe just have a little bit of help here and there. All right, but the first thing for any of these problems that you should do is you should fill in any information that we know. All right, so this is the figure that's provided for you, so we should fill in, are there any tick marks or arc marks that I can add? Anytime 2 triangles are being connected in one way, that should maybe set off a signal that it could be. It doesn't mean definitely, but there could be something that we can add. When the triangles are completely separated, there's really not going to be anything that we can add most likely. Maybe in some cases there's something that we can add to it, but 9 times out of 10, it's not going to be able to. All right. So then we look here and we say, okay, well, I have this right angle, so I know these angles are congruent to each other, and I have these sides. Well, here they both share this leg here. This is part of both triangles, so that means this segment is congruent to itself, obviously, in both of these triangles. So when I look, once I see a right angle, the first thing I should look for is HL. That's the first thing you should possibly look for. It's the one that everybody forgets. Well, here that tells us our hypotenuse in both of our triangles are congruent, and we have a congruent leg. So yes, they are congruent. Then you would need to write your congruency statement. So triangle ABD, the first one doesn't matter how you write it really, but now the second one does. So I went through 1 tick mark, through the 2, and to the right angle. So I need to go through 1 and through the 2 to the right angle. So it's triangle CBD. BD. And then the reasoning was the hypotenuse leg. So this is exactly what you'll need to do for your test. You'll have to say yes or no, or you could say not enough information. That's actually preferable. Write the congruency statement and say why. All right, so for question 12, we look here. There's nothing we can add to this. All right, there's nothing we can add to say, okay, we can add this angle or we can add this. There's nothing we can add. And we look. The angle is not included with our two sides. And we do not have a congruency theorem of SSA, or like I said, don't make this out of yourself. And since we do not have that, there's not enough information for us to say that these are congruent. So if you wrote none, or you wrote no, or what I prefer and what I want you guys to get in the habit is not enough information, right? Because if they provide a little bit more information for us to show, well, these angles are actually congruent, which there's nothing we can add to right now, then we can say, yes, they are by side angle side. But for right now, there's not enough information for us to conclude whether they are or are not congruent. So I would prefer, and this is what I want you to do, if you say no or none, I'll give you credit for it as well, but not enough information is the true, real answer for this one. All right, let's move on to the next two. All right, so here we have problems 13 and 14. So remember, first we have to determine, are they congruent? Write the congruency statement and say what reasoning. All right, so when I first look at this, remember, you need to add anything that you can. So whenever your triangles are touching, there could be something that we can add. So when I look here, here are the x that forms when two lines cross. So that means I have vertical angles here. So these two angles are congruent to each other. I know 100% that they are congruent. All right, so now I look here and say, well, I have angle, angle, side, angle, angle, side. So yes, they are congruent. We write a congruency statement. Triangle KLM is congruent to triangle where I went through from one arc mark through to one tick mark to where we don't have anything with the angles and down through the two arc marks. So that means we have to go through one arc mark through the tick mark down to the two angles. So we triangle ONM. All right, we look at this figure over here. There's nothing we can add, but there's enough information. All three of our sides in both cases are congruent. So that means, yes, they are congruent. And then the congruent triangle, I'm going to say triangle PQR is congruent, where I went through the one tick mark and then through the two. So we need to go through the one and then through the two. So is congruent to triangle STU. And then our reasoning was side, side, side. Oh, I never wrote the reasoning here. I said it out loud, but it's angle, 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 side. So our reasoning was angle, angle, side. All right, so on each of your answers, you must put all three of these if they are congruent. You saw when they weren't congruent, there wasn't anything that you could add except for just not enough information. All right, the last two questions and the video is done. All right, so for problem number 15, remember, first thing we need to do, we look, is there already enough information provided for us to say, not yet, but I see, just like the one before, that this leg is being shared, or this side is being shared with the two triangles, so I can add a tick mark there just to remind ourselves that they are, of course, equal to each other. And now, once you see the right angle, I did tell you that you should look for a hypotenuse leg first, but it looks like or seems like that's what you guys are focusing on, that because there's a right angle, it's automatically going to be HL, and that's not true. They don't tell us here that our hypotenuses are congruent, so we cannot use that. However, we do have angle, side, angle, angle, side, angle. So yes, they are congruent. The triangle, I will say, is triangle VWY is congruent, and I will put triangle. So I went through the hypotenuse and down through the congruent leg. So it needs to be through the hypotenuse and down through the congruent leg. So triangle XWY, and then our reasoning was angle, side, angle. All right, then the last one here, there's nothing that we need to add because there's already enough information. We have angle, we have side, angle, side, side, angle, side. So there's already enough information for us. So yes, they are congruent. Your congruency statement is triangle ABC. So we went from the one arc mark down through the two tick marks to the none. So we got to go one arc mark through the two tick marks to the none. So it's triangle DEF, and our reasoning was side, angle, side. All right, that is it for the questions, but I'm just going to go through a few things really quick about all the topics and make sure that you guys understand and that you guys need to know how to solve. All right, so this is a list of everything that you need to know. There's really not going to be any formulas provided for you, because there weren't really formulas on this one. The only thing I will give you is the a squared plus b squared is equal to c squared, because that might be something you need. But besides that, you just have to know how to solve them. So you'll have to know the difference between our different ways of proving triangles are congruent. Side, side, side is all the sides are congruent. Remember, here it's side, angle, side, so it's where we have the congruent sides and then with the angle in between. So it must appear exactly how it looks like in the way that we write it. Angle, side, angle is exactly the same way, where we have the two congruent angles, and then our side is directly in the middle. And then for angle, angle, side, it needs to appear exactly how it is. So it's angle, angle, and then one of the sides after it. So just make sure that you understand these. And hypotenuse leg, the key thing for here is it needs to be a right triangle, and then our hypotenuse needs to be congruent, and then one of the legs. All right. If you need help on any of these, there's videos. And if you go into your archive section, there's videos you can watch all those or come after school on Sunday. All right, here we have our relationship with our angles when we have two parallel lines. And we know that they're parallel because I give you the arrows. And our transversal. So you need to know corresponding angles and what's the relationship. Well, they're congruent. Alternate interior angles, which ones are they and what's their relationship? Well, they're congruent. Alternate exterior angles are also congruent. Same side interior angles are the only ones that are different, and they add to 180 degrees. All right, so you need to not only know these different characteristics of them, but you also need to be able to identify what is which. All right, so then our last one, our next one, are vertical angles. Well, for here, you will have to be able to know that usually they form this X-looking shape. It's where we have two pairs of opposite rays, and our vertical angles we know are congruent to each other. And this will be our pair of vertical angles there, and then the other vertical angles that we would have will be these two here. Right, and then last but not least, you'll need to know your Sohcahtoa. All right, so you need to know your sine ratio, which is opposite over hypotenuse. That's why we are using this. Our cosine is adjacent over hypotenuse, and then our tangent is going to be opposite over adjacent. And then on top of that, you need to know their reciprocals. Cosecant is a reciprocal to sine, secant is a reciprocal to cosine, and cotangent is a reciprocal of tangent. All right, so that's it for this video. There's one more thing that I want to show you to end this video off right. Sohcahtoa, 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 sine, opposite hypotenuse, sine, opposite hypotenuse, sine, opposite hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, tangent, opposite adjacent, tangent, opposite adjacent. Okay, so just make sure you guys know that. Hopefully this song is stuck in your head. We're going to watch it one more time before we take the test. All right, but if you need any help, just make sure that you guys reach out. We still have after school Sunday that you can seek help.